Hey scholars, today's objective is to continue working with expressions of exponents and exploring when the base of the exponential expression can be something different in a number. So let's read this first part together. When working with exponents, the bases don't always have to be whole numbers. They can also be other kinds of numbers like fractions, decimals, and even variables. For example, we can use exponents in each of the following ways. I could say that 2/3 to the 4th power is just multiplying 2/3 by itself 4 times. I could say that 1 7/10 to the 3rd power is multiplying 1 7/10 by itself 3 times. And I can say x to the 5th power is the same as multiplying x by itself 5 times. So big picture, the key thing to note here is that the base can be a fraction, decimal, and variable. So we're just going to continue practicing this idea of exponents with looking at some statements and asking ourselves, is the equation true or false? I'm going to model for you number 1, number 2, you'll do number 3 and number 4, and then we're going to continue on with the lesson from there. So essentially now we have two expressions and we're going to ask ourselves, is it true or is it false? For example, is it true that 2 to the 4th power is equal to 2 times 4? Let's think about that. Let's use our strategy from yesterday to note that I can write this exponential expression in multiplication form, which means that 2 to the 4th power is multiplying 2 by itself 4 times. And when I write it like this, I can think to myself, is this true? Is 2 times 2 times 2 times 2 equal to 2 times 4? If I do some mental math, the left side equals 16 and the right side equals 8. So therefore, I can conclude that this is a false statement. And I can name that this is false because they are not equivalent. They have different values. Let's look at number 2. It says 3 plus 3 plus 3 plus 3 plus 3 is equal to 3 to the 5th power. Is that true? Let's ask ourselves by first rewriting this without the exponents. So 3 to the 5th stands for 3 multiplied by itself 5 times. And when I see this, without even doing the math, it's pretty obvious that 3 added to itself 5 times would be way smaller than multiplying 3 by itself 5 times. So I can conclude that this is also false. This is false, and again, it's the same reasoning, because they are not equivalent. So just to recap some steps to take when you're testing some expressions, write them all with only multiplication and addition, or just no more exponents, and then use that to help use your mental math to decide if it's true or false, that they are equivalent or not. So what you will do is now look at the back side at number 3 and 4, these two on top, and work them out and decide, are they true or are they false? Do that now and pause here and check your work after the pause in the video. Check your work here for number 3 and number 4. Both of them are false because they are not equivalent when you write them out with the multiplication versus the exponents. Now in 5 and 6, we're going to see that we now have fractions as our base. But this should not change what they represent. So I'm going to look at number 5 and model that for you, and then you will do number 6 on your own to test if it's true or false. So I see number 5 says I have 1/2 multiplied by itself 4 times, and then the right side says 4 times 1/2. Now, if I did some mental math, I can see that on the left here, if I multiply all these fractions by each other, I can multiply all the numerators and multiply all the denominators. So I'm going to have a fraction that looks like the following. 1 times 1 times 1 times 1 gives me 1. 2 times 2 times 2 times 2 will give me 16. And then on the right side, if I write this as 4 over 1, it's going to be 4 times 1 gives me 4. 1 times 2 gives me 2. Now, this is clearly, again, not equivalent. So I'm going to say that this is false, again, because the expressions are not equivalent. So the same process, but now we just have fractions to think about when we're trying to evaluate our expressions. So now it's your turn. Try number 6, pause here in the video so you can practice this and continue whenever you want to check your answer in the video. So when you work it out for number 6, you would get 1/2 multiplied by itself 4 times, which gives you a final evaluation of 1 over 16, and therefore it's a false statement because both expressions are not equivalent. We have one more problem for you to practice, and it's going to be a question where you have to circle every expression that is equal to 3 times 3 times 3 times 3 times 3. And again, to help you, I'm going to ask that you write all of these in multiplication form without the exponents. So A will look the same. B would be 5 3's multiplied by each other. C would be 4 3's being multiplied, for 3 to the 4th, multiplied by an additional 3. D is 5 times 3. And E is 5 multiplied by itself 3 times. So using what you see here, using some mental math and some math understanding, circle all the expressions that would be equivalent to 3 times 3 times 3 times 3 times 3. Pause here and then resume when you're ready to check your work. B and C are the only ones that are equivalent. A and D are way too small, being only 3 times 5. And then E, 5 multiplied by itself 3 times, would not be the same as 5 3's being multiplied by themselves. So there's no equivalent value there. When you finish the notes and you're confident to move forward, you can take your X ticket for this lesson.